I got it.
I saw another two. I had sent Kurt a note. Working? Back in town saying, hey, you gotta send an updated list.
Oh,
It's updated, but it's not accurate.
I sent it to the wrong address. I'll send it to you tomorrow.
Thank you all again for coming. It's good to be back, and the first thing we're gonna do is the roll call to make sure, and Pat, if we don't mind. Oh, let me pull it back in. The same reminder that the mics will be on the entire time, so that if you have something funny to say and don't want everybody to laugh, you can keep it to yourself. First order of business will be to do the roll call, and Pat, if you don't mind, starting with you, just announcing who you are so that Alan can record it.
Pat Charamel with the Old Colony Planning Council.
Joe Coughlin, Town of Plymouth.
Pine Dubois, House Speaker.
Rich Grassy, Town of Plymouth.
John Flores, Governor's appointee.
Robert Jones, Health and Human Services.
Heather Leitner, Town of Plymouth.
Sean Mullen, Minority Leader.
David Nichols, Governor's appointee.
John Orenberg, Entergy.
Kevin O'Reilly, House Speaker.
Paul Smith, Utility Workers.
Joe Lynch with Entergy, standing in for Mike Toomey, who couldn't be here this evening.
Hi, Elise Magnato here for Dan Wolf, both designees of the Senate President.
John Chapman, and I am the designee of Secretary Jay Ash.
Thank you. With that, the chair rules that we do have indeed a quorum. First order of business will be to review the minutes from the October meeting. Are there any comments or corrections to the minutes? You should have all received them electronically. We're trying to do our part to save the environment. Mr. Hayden? Alan, if you could note that Mr. Robert Hayden is also here. Any comments or corrections or edits to the minutes? Hearing none, is there a motion to accept them?
So moved.
Second? All in favor, say aye.
Aye.
All opposed? Minutes are passed. So that's great. With that, let me, I've got a few quick notes before we get into the presentation from our good friend Joe Lynch, and then also questions and answers. First, a reminder, we agreed back in the summer that there will be no December meeting, so this will be our last meeting until 2018. Unless somebody wants to change that on a motion, I don't think it'll have much support. The second is, before we adjourn our meeting this evening, I'd like to go through what I'd suggest is the schedule for the first half of 2018, because we have some time now to get it properly planned, and then also to discuss the second half, not as in greater level of detail. One other topic, and Jessica is not able to join us tonight, but several members, Mr. Selectman, nice to see you. If you could add John Mahoney, Alan. Several members have talked to me, and I assumed to others, about remote access to be able to participate in the meetings when, for a reasonable cause, they can't physically be there. And could we do it through either telephonic or web-based systems? Kurt was kind enough to do some research, as he always does, which I will be forwarding to all of you tomorrow. But let me summarize it for you basically. If it is an unreasonable burden on somebody to attend in person, that can be taken care of. We can arrange for telecommunications. This may be not quite as big a deal when it comes to the regular panel meetings, but it might be more convenient for some folks for the working groups. That said, there is a pretty high burden on it in terms of what you've got to do, in terms of how the minutes are taken of those meetings, how the access is granted, when announcements have to be made. So what I'd like to suggest is that I think there's some real merit for all of us to discuss it. And we also, as a panel, have to vote in order to do this, is to distribute this little analysis and guidelines from the Attorney General that Kurt prepared, and let's discuss it at the next meeting. Is that acceptable to everybody? Okay. Since I mentioned the working groups, let me get on to just a couple of housekeeping items about the working groups. First, as you all know, you must prepare and publish a notice. Kurt's requested 2 weeks if possible. If that's not possible, really, at least a week beforehand, because as I'll mention in a moment, there are some logistics issues getting stuff up onto the website. It's not like we have our own person that just is waiting there for us to give them data to put up on the website. So 2 weeks is what we're shooting for the sites. You need to also prepare and submit to us and to the full committee for publication the minutes of each one of the meetings. I've seen some of the first efforts, and it's really exceptionally well done, even for those that may have gotten into it without wanting to. So it's well done so far. On the scheduling and logistics of it, the only one I've personally been involved with is Pine for the second meeting here, and it worked out great. Rather than inundating Kathleen Sullivan, who's the person that coordinates it for Plymouth Schools and PCIS, my suggestion is, let me know, and I'll do what I did with Pine, which is to get the two of you together, and you guys work out the dates that everybody's good for, and then I'll do the paperwork. Because, of course, there is paperwork, and I'll do the paperwork. Any questions on how this should probably work going forward? Now, there is no prohibition, of course, from holding it at a different location. So if a working group wants to hold it somewhere else, the thing you got to keep in mind is our friends from the communities may want to come, so the size of the facility and the ability to really manage it well, that's always an issue. Hearing none. Any other? Yes, Joe.
Question. It'd probably be helpful for clarification. When we have our working group meetings and we do the minutes, just like with this panel, what we then need to do is at our next working group meeting, we bring up the minutes for approval, and then they become official, and then we submit them.
Absolutely.
And so forth and so on. So just as an
From
administrative.
a logistics administrative point of view, it's a lot of work.
Yeah, it is.
So, I mean, maybe that'll encourage people not to talk that much. The other is, this is the new updated revised version of the list of members on the working groups. This has been a challenge for both Kurt and I. What I'd like to do is, Heather, just pass it over to John and we'll bring it back around again. While I'm finishing up these other notes, if you could just look at it. Only reason I handed only one copy is because I want it back, so if there is or are any changes, I will make them. So that's the working group piece. And with that, before I introduce Joe, who you all know, for the presentation, I just want to make a couple of preliminary remarks. First, I have to say that in my conversations with Joe and other folks at Entergy regarding the location of the next pads and the current ones, there's been a real openness. I've been really encouraged, and I thank you guys for the openness to really allow us to engage in a conversation about this. As I was thinking about this morning, all I could think of was your colleague, Chairman Tavares, when he was here and mentioned that he wanted us to ask the tough questions and get the tough answers and all that. I think there's some of that that's going to happen this evening. I think this is the first, beyond just education, I think it'll be an opportunity for everybody on the panel to really learn more tonight. And I know that Joe has certainly done this discussion before, and I just wanted to thank you and your colleagues, because there really is a sense of openness about this. But I think tonight's the night we start getting down to some questions. And of course, we'll encourage the public to do the same during the time that we have allocated for it. So with that, if there's no other comments? Yes, Pat?
In regards to this, if your name is missing, can you put it on there?
Absolutely, that's exactly what it is. Or if you want to change, or if you want to put it on somebody else's name to have some fun. Any other comments? Joseph, the floor is yours.
Thank you, Sean, and panel members. Thanks for the opportunity to kind of continue the dialogue on what's really a very important topic, both for Entergy in regards to long-term spent fuel storage, but also a very important topic relative to our plans as we transition from an operating plant to decommissioning. So I thought I'd start with just a little background information about the dry fuel stored on site, what's going to be stored on site, a little bit about where we've been and where we're going. So our spent fuel pool has a design and license capacity of 3,859 fuel assemblies. The reason I mention that is there's been a lot written, there's been a lot said that, you know, we had an original 880 or something like that, but the reality is that was what the design was when we operated the plant back in 1972, and things have evolved, technology has evolved, and today we're licensed for just under 4,000 fuel assemblies. We currently have 2,990 stored in the spent fuel pool, and we have about 580 assemblies right now in the reactor, which is, of course, operating in our last cycle. So when we complete our last cycle on or about the end of May 2019, we'll be adding another 580 fuel assemblies to the spent fuel pool. Right now, we have 544 spent fuel assemblies stored in 8 dry casks on the first of what will be 2 independent spent fuel storage installation pads. So since 1972, when we went commercial and started operating the plant, a total of 4,114 fuel assemblies would have been generated.
Hold on one second. Justin, if you could hear me, can we get the other screen to go down? Or Kevin, maybe you can just try pulling and see if it works. I'm not sure it's on. Yeah, I don't know where that is. Yeah, can we do that one too? I was gonna say, Kevin, you were gonna have to sit on the, yeah. Go ahead, Joe.
Thank you. So continuing a little bit with kind of the background information, as I had mentioned, we currently have one operational ISFSI pad with a 40 cask design capabilities, but what we'll do is we'll administratively limit that to 38, because I think I mentioned at the last meeting that we have to have the ability to shuffle these things around a little bit, to move them, to do inspections and things like that. The one pad that we have construction does have the 8 casks. These casks are designed and fabricated by Holtec. They're known as their System 100. It includes an inner canister which holds 68 fuel assemblies, and then an outer overpack, or high storm as they call it. This is the heavy concrete and steel shielding that goes around each cask. We do have plans to continue the loading campaign into 2018 and likely 2019 prior to shutting the plant down, but we don't have those precise numbers, but we're working on that right now. So based on the numbers that I provided to you, it's obvious that we're going to need a second ISFSI pad to store all of the spent nuclear fuel on site. So what's involved is design, engineering, eventually a vendor selection will determine the actual specifics on the size of the pad, physical size of the pad, and the number of cast systems. So right now, as I had mentioned, we're using the Holtec System 100, but because we're likely going to need, you know, upwards of 50-something more casts, we will be prudent and look to other vendors to see about whether there's more economies in going with a different design. But up to this point, it has been the Holtec system design. This is probably hard to see, but I wanted to give you a couple visuals of where the cask is relative to some of the features for the site. I don't know if this pointer actually is going to work very well, but down in the lower left-hand corner, you can see kind of a blue flag. That's pointing at the pad, which runs right along that section of the drawing. The intake canal is the middle arrow, kind of points to where water actually comes into the site. The breakwater, which is a physical structure, a jetty that was constructed as part of the design. We have one that's kind of sets the area that's called the intake structure. We have another one that borders the beginning of the intake structure. And then the discharge canal kind of runs out and up the left-hand side. So that kind of gives you a configuration of where the pad sits. Since all of you now have blurry eyes and can't see anything, I put up a picture that actually looks a little better, which is a photograph, an aerial photograph of the site. So again, down in the front, right above Mr. Smith, you can see the pad. Right now, in that photo, it only shows 3 canisters, so this was a couple of years back. And again, you can see the breakwater on both sides of the intake structure, and you can see the discharge canal in the lower left-hand corner. So you can see the position of the pad. It's roughly 300 feet away from any sort of resource, any sort of a shoreline or water feature, the closest being the man-made intake canal, and you can see where Cape Cod Bay is relative to the pad. So the effort to site the second pad obviously is an extraordinarily important project to the overall decommissioning. And I had mentioned in the introductory presentation I made at the first meeting that one of the major projects we're working on is the development of what is known as the post-shutdown decommissioning activities report. We have a working group focused on that. That particular report will focus on three things: a very detailed cost estimate, it will have the overall plan and schedule for decommissioning, and it'll have a plan of what to do with spent fuel. This is a requirement before the NRC. We have to submit to them an updated, what is known as a radiated spent fuel management plan. And in that plan, we need to have how we're going to store the fuel, when are we going to move it, what methods are we going to use, and there's different options. As an example, most people think that when a plant shuts down, they move their fuel to dry fuel storage, and that certainly is the majority of plants in the United States. Millstone Unit 1 in Connecticut still stores its spent fuel in the pool, and they've been shut down for much greater than 10 years. NRC has been out there saying that you can store fuel safely both in wet and dry. Both technologies are very acceptable and have been used for a very long period of time. But we're going to need to define that in our PSDAR. Our plan is certainly to move all the fuel from wet to dry as soon as reasonably possible after we shut down, given there's certain physical constraints, including cooling of the fuel before it can be moved, especially the fuel that was most recently offloaded from the reactor. As you can see from this list, there's a lot of regulatory and technical requirements that will guide through the process. And this really came from the work that we had to do to site the first of the two ISFSI pads. So we need to identify the storage capacity and layout, the configuration of where this pad has to go relative to getting the fuel to it, interfaces and subsurface utilities. So this is obviously a very massive structure, so we have to take a look at what's underground, what things have to be protected, what things have to be removed, whether it's utilities, piping systems, electrical interfaces. Obviously, with a large industrial facility, we have a lot of subsurface structures and commodities that we have to be very careful about. Regulatory requirements, very specific NRC, Nuclear Regulatory Commission requirements, as well as local requirements, local permitting. Geotechnical, we have to look at the soils. Physical design criteria, such as the structural design and the electrical interfaces. Security requirements, radiological considerations. Once this gets put in, we still have to meet the requirements for the NRC relative to any radiation dose coming from this to members of the public. Hazards consideration and impact on decommissioning. And that last one is you can't just put it anywhere, because we have to also dismantle plant once the dry fuel storage facility has been completely installed and all the fuel has been moved. So kind of stepping down each of these various regulatory or engineering challenges. The storage capacity and layout, the capacity of the new pad will accommodate all of the spent fuel in the spent fuel pool, including, that's in the reactor right now, the 580 assemblies, in coordination with the existing pad. So the existing pad can hold roughly 38 assemblies times 68, and, do the math, around 2,000 fuel assemblies. The capacity of the pad will also include additional storage spaces for what is known as greater than Class C waste. So when we take apart the reactor vessel itself, the metals that are right around the core, or what used to be the core, that metal is very activated. It has high enough radiation levels when the plant is shut down that it can't just be shipped anywhere. So that's what is known as greater than Class C waste. I can tell you right now that the Yankee Row, Maine Yankee, and Connecticut Yankee plants store some of that waste in casks on their ISFSI pad. and that is allowed by NRC regulations. So we're at least going to make provisions for having additional space on our pads in the event that we decide to cut up the reactor and leave some of that material in the casks until such time we can ship it to a repository that takes greater than Class C waste. We're going to assume that this is going to be a concrete pad, similar design. There's a lot of different designs out there, or at least a couple different ones, but Entergy as a fleet has used the pad with a vertical cast type design. It'll consider effects of stormwater runoff and drainage, and what means by that is the pad we have right now actually is sloped. On one end it's 25 and a half feet above sea level, on the other end it's 25, so any rain or runoff can go off the pad and not stay on it. That will be part of the design. The pad layout design shall be suitable for a vertical cast transporter. What the heck is that? Well, it's a very large device that has to move around these 173-ton casks. So we have to design this cask so that we could get this transporter to move the casks around, move it to the pad. So some of the locations that I think people have been talking about up on the hill, across the street, may not be physically possible given the equipment that is available to move these things around. There are massive concrete and steel structures that weigh a lot and have to be moved very slowly, so that will have to be taken into account. And we'll just assume in the initial design phase that what we're going to design is compatible with the Holtec 100 system, since we know the design criteria of that. But as we select whether it's Holtec or somebody else in the future, we may be able to modify it, but we're going to do a most limiting case up front. I talked a little about these interferences in subsurface utilities. So we're going to have to take into account all buried utilities. That'll include electrical, security cables, piping system, leach fields, stormwater systems. Within the pad footprint and around that, they have to be evaluated for the design loads. This massive pad is many feet thick with lots of rebar, so it weighs a lot, and then you have all of these casts put on top of it. One of the reasons I mentioned leach fields is that one of the locations that is being looked at is this upper elevation on the plant, which is currently has a building. It actually has our septic plant as well, and that whole area is leach fields. So if we were to look at that, we would have to relocate the septic system at the plant. It's a pretty elaborate state permitted system. We'll also consider the complexity and impact of relocating those underground commodities. So we may identify certain things, but some things we may not be able to move because we would have to take them out of service, and they're either supporting plant operations right now, or even when we shut down, they may be needed going into the future. We'll customize the design to accommodate any of these things, so if we can work our way around them, obviously we will. And we actually have a preliminary survey of what all the electrical utilities look like underground, because we have a very good system of drawings. And what we'll do is likely use ground penetrating radar or some of the more recent techniques to make sure we know everything subsurface before we go forward with making a decision on the new pad location. Regulatory requirements, I can probably put you to sleep if I went over all of these, but these are very, very important regulatory requirements from the Nuclear Regulatory Commission. They're really broken down into just a couple sections. 10 CFR Code of Federal Regulations Part 72 has to do with the storage of fuel. They have a subpart E entitled Siting Evaluation Factors, and then within there they have a number of chapters. I just picked out a few of them to give you a highlight of the type of things that we're going to have to consider. Design basis external events, so flooding, earthquakes, tornadoes, hurricanes, those type of things. Design basis external man-made events, things like if we have storage tanks with gas or fuel, and we have to design around explosions and fires and things like that. So based on where we site this, we have to take into consideration what's being stored at the site right now. Geological seismic characteristics, those all apply. The seismic considerations that we have for our design will go into the pad as well. And then also how we get the fuel off the site. So they want you to take a look at where you're putting this, also lends to the future transportation off-site of high-level radioactive waste material. At Pilgrim, I would guess either by barge or by truck would be the options that we'd be looking at. In Vermont, for example, we have a rail spur, so that might be the most likely use. But that has to be taken into account, and the NRC regulations actually drive it. The second section, subpart F, talks about general design criteria. So this is essentially how you build the pad. Also talks about radiation protection. While these canisters are very well shielded, when you put 38 and 40 of them together, they may have a dose consequence. That has to be taken into account. The fencing systems around them, the boundaries that we have to establish for ensuring that people don't receive more than the dose allowed by Part 20 of the regulations, which is a 25 millirem per year dose. So all of that we'll take into consideration. And then that last one, 72-130, is what I had mentioned earlier. The NRC has regulations that says you have to take into consideration the ability to decommission the site while you simultaneously store the spent fuel. The other part, Part 73, subpart H, is physical protection. So this is where all of the security requirements come in from the regulator. So you have to have a physical protection plan. You have to design your pad and all of the systems around it to protect it. And you also have to treat all the information having to do with this pad for security as safeguards. And we, of course, have a safeguards program. So that doesn't go away when we stop operating the plant. Safeguards is clearly something that we have to consider going into the future. Local permitting, working with the Plymouth Board of Appeals for a zoning permit. We'll go through the Conservation Commission for a determination of applicability. We would expect, based on where we locate it, these would be outside of areas that you have things like wetlands and all that, but that has to be taken into account. And then finally, we'll need a permit to do the construction of it at some point in the future. Geotechnic, the site must meet subsurface geological and seismological design requirements, much as anything that we build on the site. And we have design basis requirements for that right now, so they would be transferred to the design requirements for the pad. We also have to meet certain NRC requirements, and that establishes for this area of the country what are those seismic requirements, what are those design considerations. And one of the things that's very important, the cask also has to be designed for what they call dynamic loading. So in the event of a seismic event, the pad has to be stable. The cask shouldn't move, even though they're very massive. You have to design that. And another important factor, which turned out being a design challenge in Vermont, is what they call soil liquefaction. Under certain seismic events, the soil, while stable under a normal environment, under a seismic environment, the soil can actually liquefy and move, and the pad would settle and change positions. So all of that has to be evaluated, and we do core bores. We have to evaluate the quality of the material. In many cases, we have to excavate a very large area and then put back in what they call engineered material that's designed to address this soil liquefaction. So in Vermont, we built the first pad. We built the second pad right next to it. We did some of the core bores, and they didn't come out exactly the way we thought they would. They took some additional engineering before we could demonstrate that the location of the second pad actually worked out very well from a seismic standpoint. Engineering design considerations, pretty straightforward. Structural design, it has to meet the cask designer's requirement and what is known as their final safety analysis report. So these casks are licensed by the NRC. They come with a certificate of conformance. They also come with a final safety analysis report, everything about these casks. So we then have criteria that will then be used to design the pad and all of the systems around it. We also have to build it in accordance with a lot of the industry standards. ACI is the concrete standard, so compressive strengths of materials, things like that all have to be factored in. And then the structural design has to take into account all kinds of loading combinations. It goes back to your seismic in combination with other events. Things that we do normally when we design anything at the plant, that all applies to these, something as simple as a concrete pad. Electrical design, pretty simple stuff, but really important. The pad has to be grounded. We have to have adequate lighting because it is part of the security plan. One of the things that's required by the license is to do temperature monitoring, so we have to bring the systems out there to do monitoring. We monitor the temperature going into the cast and coming out of the cast. We measure the change in temperature, and it demonstrates there's nothing going on in the way of blockage, and that the cooling, which is natural circulation, is happening properly. And then we're also going to have backup power. So as we normally do when we operate the plant, we have normal sources of power, backup sources of power, and then a series of emergency diesel generators. We would have to have the same thing here, both for operating the equipment and making sure that the security system around the pad is operating properly. So that'll be factored into the design. Security requirements, can't get into a lot of the details, but as you can see, there's a series of regulations that the NRC imposes on us, both in Part 72, which is the cask in ISFSI design, and then Part 73, which is the security requirements. We need to locate the pad inside of what is known as a security owner-controlled area. So the first pad is inside of the security owner-controlled area that we have maintained as part of the operation of the site. If we were to move it outside of that, we would have to construct the same type of robust security barrier around any location. It would have to have monitoring, 24/7 security coverage. It would have to have all the requirements imposed by these regulations, and it would have to meet NRC criteria, inspections, things along those lines. So all that gets factored into wherever we're going to make the decision. Also, it determines certain things like minimum distances, where the fences have to go. All of that gets factored in and will be part of the design once we complete the siting study. Radiological considerations, it'll consider site boundary dose in accordance with some regulations, but it gets back to Part 20, which is part of our operation is that any member of the public should be able to walk anywhere around the outside of the owner-controlled area of the site and not pick up more than that annual dose that's required by the NRC. Same thing would hold true here as part of the design of the first cask in combination with the second cask. Even if they're far apart or close together, we still have to make that determination. And then there are also radiation protection techniques that are factored in by NRC regulations. Hazard considerations. So I spoke a little bit about fire and explosives, and that certainly is something that we have to take into account. Part of the cask design is NRC license requirements is they'll get a certificate of conformance, and it'll say what these things are designed to take. So they're designed to take certain natural events. They're designed to take things like explosives and all that, but there's going to be limits to that, and we certainly can't create a situation because of what we have on site right now that would introduce something like a fire or an explosion. And some of the things we'll look at is where we're storing fuel, where we have transformers that have oil in them, and things as simple as forest fires. You wouldn't want to locate this in an area where a forest fire could get so close to the cask that they could cause, a design issue or the ability to fight the fire or get to and protect the casks. Explosions, again, we have on-site gas storage, we have hydrogen and a few other things that we use as part of normal operations. Underground piping systems, and then storage of combustibles all have to be considered when you locate the pad. The other hazard evaluations that we'll have to go through, again, part of them are listed in NRC regulations, have to do with kind of natural events, flooding, earthquakes, tornadoes, hurricane, and then the effects of things like hurricanes. So, tornadoes. So if tornadoes picked up materials and they get flying through the air, those are what is known as tornado missiles. They have to take the impact of the worst case tornado missile. So again, we have to locate this pad in an area where we can say that there's nothing stored in the site that can become airborne and become a missile and therefore cause damage to the cask. All of that would be factored into our design. So I wanted to spend just a little bit of time about flooding because I think it's been one of these topics where we've heard a lot of information about whether the existing cask storage system and pad is located properly relative to the potential for flooding. And obviously, if we understand a little bit more about that, it kind of sets the, kind of the standard for the second one and hopefully alleviate some of the questions that are out there. So first, the existing ISFSI pad is located at elevation 25 feet above mean sea level. I actually said earlier it's 25 feet 6 inches on one end and it slopes down to 25. So at the minimum, it's 25 feet above mean sea level. The pad's located about 300 feet from the closest shoreline. Each Holtec High Storm 100 cast system, completely loaded and on the pad, weighs roughly 173 tons. And each of these casts are about 18 feet tall, 18 feet 3 inches, and about 11 feet in diameter. So that should give you just a little bit of an idea of the magnitude of how large these things are. Some of the definitions that have been talked about: mean sea level, that's the average level of the ocean surface, calculated for all stages of the tide. And that's kind of what we use as our reference point. You'll hear us talk about 25 feet above mean sea level and, surges and things like that. Mean water level is a datum derived from an average of all the low tides that we've had over a 19-year period. That's just part of the standard. Mean high water level is the same thing, average of all high tides for a 19-year period. And then the maximum astronomical tide is the highest tide, which can be predicted to occur at any given location. So all that information is available to us through either data that we've collected or data that's readily available for this part of the country. So back when we designed and sited the first pad in 2010, we did do a flood evaluation to ensure that the height that we selected was going to be protective of any sort of postulated flood for the Pilgrim site. And then, as it turns out, in 2015, we went through a very detailed and exhaustive reevaluation of all kinds of natural events because of the terrible accident at Fukushima. So one of the things that we had to do to meet NRC requirements was to do a complete flood hazard reevaluation. That was in the form of a report. It was submitted to the NRC back in 2015, along with all the other information we provided to address all of the various task force recommendations that the NRC imposed on all of the nuclear power plants in the United States. So we have a very new and up-to-date flooding evaluation, which was done for different reasons, but is certainly applicable to anything that we do going forward for constructing a second pad. Both of these evaluations, even the one back in 2010, as well as the one that was updated in 2015, have concluded that the elevation and location of the first pad is acceptable and flooding is not a design criteria or an event that we have to be concerned about going forward. So probably something difficult to see, but this is one of the figures that's in the report that we sent to the NRC. And what each of these arrows that are kind of coming in, one you can see comes in right straight through about where the intake and discharge canals are. That was one wave effect, if you will, or one flooding effect. Another one was done a little further over, kind of right behind our reactor building, just to the right of those two tanks that you see. And then the last one kind of came in from an angle. And the reason for it is if you have any sort of wave effect or high tide effects, you notice we have the breakwater, and it has an effect on lessening any sort of impacts from wave action and flooding before it gets to the actual shores of the plant. So we also looked at a case where essentially the breakwater was not there. And I'll show you the results of that. So this is kind of a summary of the flood hazard reevaluation. So the three mechanisms, the first one, probable maximum hurricane plus wind effects upstream face of the intake structure, that all goes back to the arrow off to the left. So as the effect comes in across the breakwater and onto the site, the still water evaluation, so that's what the new elevation of the ocean is given this storm, is about 15.8 feet above mean sea level. The wave run-up at the site, as calculated by this study, was an additional 4 feet. So the maximum flooding for that left-hand arrow is about 20 feet above mean sea level. Remember, the pad is at 25. The second one, probable maximum wind, storm plus wind wave effects near the reactor building. I didn't make any of this up, by the way. Shows that, again, the still water elevation was about 15.3. As it came up, this is the center arrow, red arrow coming into the site right behind the reactor building. It has a wave runoff of 7.1 feet, so a total reevaluated with this new study in 2015 showed the maximum mean sea level would be 22.4 feet. And then the last one, which doesn't take into account the breakwater, again, used the 15.8 feet as the still water level, had about a 6.3 feet wave run up, and the total impact on the site at that location was 22.1 feet. So as you can see, we have margin for all of the scenarios that were done as part of this flooding reevaluation study. This was submitted to the NRC. It was approved and accepted by the NRC, and it forms kind of our basis going forward for how we take into effect flooding at the site, and would apply going forward to siting a second ISFSI pad. So really, in conclusions, the effort to site the second ISFSI pad is obviously a very important project to the decommissioning of Pilgrim and to the management of spent nuclear fuel. Again, it's an NRC requirement. It's going to be in the PSDAR, and it's going to be informed by all the regulations and technical requirements I described. There are numerous regulatory and technical requirements that will inform this process. It'll guide us, it'll influence us, it'll limit us in some cases. We'll have more and more information available as the selection process and some of the engineering is being done. And we plan on keeping this membership group up to date as we move through that. How you can provide comments is really up to the chair. If you want to send them all through through either Kurt or Sean, we'd be more than happy to address those, take those into account. I know there's a lot of information out there. There's a lot of input that people would like to have. We would do our best to kind of take that into consideration. But what I wanted to do this evening was really give you an appreciation for, what we have to look at to meet regulations, to meet the design of the CAS, to make sure it fits properly on our property, to make sure it's properly secure. But we also recognize how important this is as a stakeholder issue. And so I wanted to give you some of that background and some of the things that we have in front of us going forward. So,
Thank you, Joe. We appreciate that. I think from a questions point of view, we've allocated about the same amount of time as Joe. And I think the fairest way, we'll start with you, John, and we'll just go around the room once, and then, so everybody gets a chance to ask at least one and then more. So if you don't have a question at first, or you want to formulate something based on, you can just pass your time over to the next person, and we'll start with you, John.
I pass it over to the next person. That was a thorough presentation. Thank you.
Joe, just a quick question in regards to safety on these casks. Is there any way that if anything happened to them that they need to be either overhauled or anything like that? Is there anything that could go wrong like that?
well, they're a fairly simple device in that there's no moving parts, there's no forced cooling. The inner canister is a stainless steel canister, so it certainly is designed to not have issues with corrosion and things like that. They have a design life. They have to, or I shouldn't say a license life, that they have to be updated every so often. I think initially these have a 20-year license. Then the manufacturer would have to go to the NRC to extend that license and demonstrate for various reasons a good maintenance program, a good inspection program would make sure that they're good for many years going forward. You know, I would say something the panel might consider for the future is to have someone speak on the design of these things. They can certainly speak more. I know Dr. Chris Singh, who is the designer and CEO of Holtec, did have an opportunity to speak at the Vermont NDCAP. I'm sure he would do the same thing here. But he can probably give you a lot more about the assurances of the design. To the best of my knowledge, none of the Holtec casts have ever had a leak. I think I talked a little bit at the last meeting, but these are all loaded underwater in the spent fuel pool. Once the 68 fuel assemblies are put in there, it's taken out of the pool in a shielded cask. It's then drained of its water. A very robust lid is welded on. It's then vacuum dried, backfilled with helium, and essentially you have your sealed canister. Then that canister is put into this overpack, which has, roughly 2 feet of concrete and steel shielding. Another lid goes on top of that, and then it gets stored out in the pad. So, not a lot of, mechanisms for the cast to degrade, and all of that is taken into account into the design.
I was just thinking if you got rebars going around in the cask and stuff like that, those eventually, if moisture gets in them, they eventually,
The
rust
whole
out.
tech design is steel on the outside, steel on the inside, so the rebar and any sort of reinforcement bar is encapsulated. There are other systems out there where there's an inner steel kind of shell, and then the concrete is exposed on the outside. We don't have that particular design here, so I think it lends a little bit more of that concern you might have.
Joseph?
Thank you.
Question on the second pad. You went over all the kinds of considerations that you'll have to take into account in locating it and siting it and building it and so forth. I would assume those same kinds of considerations were taken into account for the pad that's already there.
That's correct.
One of the things you mentioned caught my attention, the liquefaction of the soil. Many people may remember a number of years ago, I think the last public story on that was at the Marina District of San Francisco, where there was a quake and buildings collapsed 2 to 3 stories just straight down into the soil. But that was because that was all fill, unconsolidated and uncompacted fill, so that's what happens. Is there any indication that the general area where the second pad would be placed has any kind of fill like that, and/or was there any of that kind of fill for underneath the first pad? And if there was, what was done about it?
Right, so what we would have to do for the new location and what we did for the existing location is to do a series of core bores, and these core bores are then sent off to a laboratory, and they analyze the material structure and make a determination as to whether that soil has the proper soil stability, compaction, and in some cases you have to remove a layer of it and put in this engineered fill, which is material suitable for the pad. So before we did anything, we'd have to go through that entire geotechnical evaluation of any location.
Yeah, a couple of need for clarification, I guess. When you first started talking about the pad, I thought you said that it sloped and that one end was 21.5 and the other was 25. And then when you concluded, you said it was only a 6-inch difference. Can you clarify which one it is?
Yeah, I apologize if I misspoke. So the pad on the average, or the lowest, I should say, is 25 feet above mean sea level, and on one end it's 25.5. So it has roughly a 6-inch slope across
Oh, it's a
that
6-inch
full
slope.
dimension
And is
for
it,
drain
so
off.
is it a east to west slope, or is it a north to south slope?
I don't want to speculate on that answer. I think I know what it is. I think it's a north to south, but I'd have to verify
Would make the most
that.
sense, but
Yep.
if we could get. Just following the order of your presentation, the leaching fields, you said from the wastewater treatment plant on the upper level where the helipad is and so on and so forth, you said it was, you seemed to say that it was under that parking area. My understanding was that it was in the field next to Rocky Hill Road. Can you clarify that?
They're in various locations, and
So there's several of them.
yeah, and I don't know if they're actually under the parking lot, but I do
Can you
know.
get us a site map of the leaching fields?
Oh, yeah, we have all of that.
That from you?
I can certainly take a look into that for you, but I don't have that as local knowledge. I just know that one of the constraints in that elevation is the fact that we have the, not only the system, but we also have fields that we'd have to take into account.
Yeah. As to the Arriva report, we at Jones River spent a lot of time on the Arriva report. In fact, we hired another consultant to look at that. And we had some serious problems with it, mostly in relation to the fact that the sea level is changing. So your mean sea level, for instance, of 15.8, was a mean sea level probably around 2003. mean sea level has come up a foot since then. And so, I think it's important for the company as well as the public to understand that report is not a stagnant report. There's also was some question about the datums that were used and the relationship of those datums, as well as like the FEMA, 100-year flood. That is a 19-year window, but it started in 2001, so we're almost out of it, right? So that stuff is old, and I think that it would serve us all well to try to come to terms with, that changing pattern as well as, the waves. The other problem that we had really with Arriva was that they did focus only on the hurricane. And our problems in this area, in fact, the problems at Pilgrim, stem from serious nor'easters, like in 1978 when that jetty was blown out. So, because those storms last 3 years during three days over multiple tide cycles, they have a different and significant impact, and Arriva did not consider that. And finally, you keep saying the pad is 300 feet from the coast. The furthest we could get it away was 120. So, the far end of the pad, the western end of the pad might be 300 feet from the intake. But when you have it full, the first casts are going to be a lot closer. So, so I think that needs to be clarified both in your presentation and just in terms of the way people look at it. Because when FEMA or others talk about, these guys, that flood zone that's over there has to do with, risk to residential properties, basically. And it's based on if I'm correct here, a 2-foot surge and a 3-foot wave. And we get more than that. The Juno storm, for instance, was a 4-foot surge. What you had for waves over there, I don't know. But because we have a facility right on the tidal river, we know for sure that everything's coming up quite a bit. And so I don't rest easy on the notes from Arriva. And I think that, as time goes along here, especially in your PSDAR, by 2019, there's going to be new datums coming out, or new information coming out on those things, and I think we need to pay attention to that.
Commissioner?
Thank you for the presentation, very informative. The question that comes to my mind is with, all the siting requirements and the federal regulations that you have to comply with, I was curious if you had a general ballpark time frame as to when it could be completed and what the cost might be.
Yeah, I may look to John to help me out a little bit. We're right now in the very early stages of gathering all the design information. So the next step would then to go out and get an engineering firm that is, essentially set up to do this type of work. I would venture we're probably looking, close to a year out, 9 months to a year out before we would be in the final stages of the selection and the design and all that. Costs, I couldn't speculate at this point until we know where and, how, if we have to extend the haul road. I didn't talk about the fact that, we have a reinforced road, if you will, that was built for this transporter to get the casts out there. If we have to substantially extend that beyond where it is right now, there would be, certainly costs associated with that. So it's a bit early for a detailed cost estimate. But I think we're looking at probably having this design detail in 2018.
Rich?
Thank you, Joe. Who develops the specs for the cast? Does NRC or Holtec? I presume it's Holtec.
Right, the actual design specifications are designed by, are developed by Holtec and then approved by the NRC.
Approved by the NRC. Are they tested by the NRC?
Whatever testing requirements usually are borne on the manufacturer, and then they have to demonstrate to the regulator that it meets whatever testing requirements.
Short-term testing, not long-term testing, but they do have Holtecs that currently contain fuel rods at other sites that are holding up. So those are also examples, right? the
Yeah,
reliability?
I don't know when the first Holtec's were designed, but I think the technology's been in place for, since 1986. So I think we're coming up 96, 30 years.
Any competitors to Holtec?
Yeah, there's multiple, NAC International, Transnuclear, to name a couple that I'm aware of. But yeah, there are.
They all approved?
Yes, those are all
They all
approved designs.
multi-purpose?
NAC certainly is. I don't know about Transnuclear. I'm familiar with NAC because that's the system that the Yankee plants use. So I'm familiar with what's Connecticut Yankee, Maine Yankee, Yankee Row.
Holtec cost competitive?
I think so. I think that's all part of, the evaluation you do. It's design, it's safety, and it's cost are all factors that go into, who you select for storing your fuel. And part of it is, are they going to be around for a while? Because you obviously would want to make sure it's a company that's going to be able to service their equipment, that kind of thing.
Thank you, Joe.
John?
Yes, thank you, Joe. Good presentation. Just a quick question, following up a little bit on what Pine was talking about. When you showed us the charts that talked about a potential storm surge, have you taken into consideration the ultimate perfect storm, a Category 5 hurricane with an astronomical high tide impacting the pad itself? I didn't see that there.
I don't know, to be honest with you, John, I'd have to go back and look at the report. I do know that the report was completed in 2015, so it's a fairly new and current report. It did revise the characteristics, the limits that were in some of the early analysis, especially in our own final safety analysis report. So we have our own design report for the plant. And so when the plant was designed, it had certain criteria for flooding, and that was revised as part of this reevaluation program. So, I respect all of the reviews and analysis that Pine has done with her organization, but I literally have a copy with me, and so it's fairly new. I don't know, I gave you kind of ones that I thought were the most limiting. I didn't see any flood heights that were higher than what I pulled out of.
Thinking of an extreme set of circumstances when you do have that perfect set of conditions where
Yeah, that's-
it's a Category 5, it's the highest winds, it's an astronomical high tide.
Right.
And that's what I think that has to really be the bar, I think, that you set.
Right.
So that it could withstand probably worst-case scenario.
Yeah, no, that's an excellent question. And the other thing that I think would be very important, and again, this is merely a recommendation, it kind of goes back to the cask manufacturer. What happens if their cask is wetted? What if it did have exposure to a foot or two of water for 3 days or a day? Does it have any impact on its function? Those kind of questions, I think, would be best directed at the people who have designed and licensed them.
Yeah, and I just have one other quick follow-up. As much as we are concerned with, obviously, the safety of the public, as this begins to be decommissioned, are there special procedures that the workforce who are going to be dealing with this from a safety perspective? I'm concerned that what kind of professional development is done for the employees to be sure that they're safe, because they're the most vulnerable folks right now working there.
You mean working around the cask? Or just?
When the decommissioning actually takes place, is there anything kind of special training that Entergy or the NRC requires?
First of all, we're going to maintain our Part 50 license, so we're going to have all the training requirements, all of the things that are imposed upon us as an operating plant. All of our workers, whether they're trained as maintenance mechanics, electricians, and all that, all those procedures will remain in place. And then, depending on whether we self-perform or service out, some of this work, you bring in, skilled workforces, but that would not change the requirements that we have for protection of our own workers going forward.
It's just a concern from the
Yep, no, that's
folks
a good-
working, I want to be sure they're safe.
Excellent question. Yep.
Before we get to you, let me just say that we're obviously very interested in this running a little longer. Do you mind spending a little more time with us on the questions, answers?
I
Because
have
I
no
also want
problem
to
with
give the
that.
time to the public
Yep,
as well.
no problem at all.
Well said. Thank you.
Just real quick, Joe, and thank you for coming tonight. Great presentation. Is this presentation going to be made available to the panel?
Yes,
Okay,
I'll send a copy to the chairs
okay.
for distribution.
You had mentioned transportation of the cast. For clarification, that's with the fuel rods in the cast, or is that
You mean ultimate disposal or?
Right, right.
Yeah, so the inner canister would never have to be unloaded. Once it's welded and vacuumed and backfilled with an inert gas, that canister will stay the way it is. It would be removed from the concrete overpack and put into what is known as a transportation cask. Those are what is known as intermodal. Some of the designs have the cask then laying down and put onto a skid. Then that skid can be put on a barge, a truck, or a train to be transported to its ultimate disposal storage site, whether it's temporary or permanent federal repository.
Is there a requirement for the period of time it has to remain on the pad before it's transported?
No. It can be moved right away.
Okay. That's it.
Heather?
I have a question. You were saying that you're gathering information and doing analysis for where the second pad might be. Is it a general assessment, or do you already have one or more potential sites that you're sort of focusing on? And if so, will you be able to make that available to us?
I think at this point, it's too early. We're really just gathering all of the design inputs. Part of it is making assumptions about, how many additional casks are going to need, kind of bounding the size of this pad. Is it going to be similar to the existing one? It appears it's going to be a little bit smaller. But right now, we just have small engineering team that's just kind of gathering all the information. And then when we go out to bid, we're going to ask the engineering firm that's going to design this to come up with a number of options that we're going to have to evaluate. We did have a siting study done for the one that put us in the location we have right now. That will be provided to them so they can at least look at some of the things that were already considered. But at this point, I would just be speculating whether it's going to be, near, far, large, small, rectangle, square.
I just have one more follow-up question. The first pad, it was located where it is because it's close to the reactor building and ease of transporting to the pad. Are we right to assume that that's probably has a good likelihood of where it might go? In other words, next to the first ISFSI pad?
Well, I don't, I would be speculating to say whether we're going to target something very close or have to look at another area. I do know on the original siting study, there was locations that are nowhere near where we have it right now. A lot of it has to do with this substructure interference as one of the first things that I talked about. For better or for worse, we put a lot of stuff underground at these plants, electrical cables, conduits, things like that, and a lot of them are active. And to move them, in some cases, is impossible, and move in other cases is something logistics that needs to be worked out. That's all of that decision-making that has to be factored in.
So as it becomes more clear to you, you'll communicate that to us?
Yeah,
Okay.
absolutely. Give you
Thank you,
updates.
Joe.
Sure.
I'll defer, because most of mine are process questions, to the selectmen.
Joe, so if we're operating under the assumption that you're going to stop producing electricity around Memorial Day weekend of 19, the second pad will take care of everything that you produce from now until then, everything currently in the spent fuel pool, and just cover everything in its entirety between both pads, right?
That's correct.
Okay. You just mentioned, there was a question earlier about the time frame. You said about a year or so for design and engineering.
Mhm.
And then once that's complete, that's when you would go in front of like the local ZBA and look for the local permitting?
Yeah, I think in order to get the local permitting, you have to have a design that they can review and comment on and consider.
Okay. And then the first pad, did the cost come in around $150 million?
I
know
don't.
Initially, they talked about that being about a $150 million investment. Is that where it ended up?
I don't know that.
I
So
don't have the figures for the first pad.
Okay.
I can certainly get that and get that information out.
Right, and that money, again, where does the funding come from to construct the pad?
I'd have to get you that information as well. I mean, certainly the first pad was constructed from, our revenues, was put into our budget.
Okay.
And it was, paid for out of
No,
a
but
capital.
it's all coming from Entergy, it's not federal subsidized?
No.
Okay.
No, well, let me caveat that by saying that, you know, once you construct these pads and you buy the casks, you then have the opportunity to go back to the Department of Energy and sue them for the
not
monies
having-
you spent because they didn't meet their, the contractual
Not
obligations.
providing you with the opportunity for the repository.
Right, so there is an opportunity to recapture the majority of the costs. Everybody has done that, and as have we. We've had at least one successful go-around with the DOE to recapture some of the costs associated with the first pad and the
Okay, thank you.
first loading.
David?
Great. Thank you, Joe, for the very informative presentation. I was surprised that you deferred comments about what would happen to the casks if they were underwater. Is that because you guys felt that it would never happen and so you didn't look at that?
Well, I've had the benefit of a presentation by Dr. Chris Singh of Holtec, so I know what he's going to say. These things can be submerged and they'll dry themselves out. The inner canister is warm to the touch, so once the water is receded, you essentially have vents on the bottom and vents on the top, and the system will dry itself. But I'd rather that come from the experts than my interpretation of what he said. But they can be wetted and they can function perfectly afterwards. I don't think long-term they could be underwater for years.
Right.
They're not designed to do that. But I do know they are capable of taking some amount of water and working just fine afterwards because they're a fairly simple device that self-drains and self-dries itself. And
Okay.
and that's all you really need is air circulating to make them work.
Okay. And then the decision to use mean sea level versus mean high water, is that, I mean, it seems like from a worst case scenario of a high tide, that would be a better reflection of what potentially could happen at the site versus mean sea level. Is there some thinking behind why you chose mean sea level versus mean high water, just to understand? And what's the spread in distance between, I mean, you had about, anywhere from 3 to 5 feet difference in where the pad site is to where the mean sea level could come. What is that? How does that spread narrow if you use mean high water?
Well, mean sea level is just a reference point. So our whole site is based on mean sea level. So grade level at the plant is 23 feet above mean sea level.
Okay.
So it's just something that the industry uses as a datum point. You could pick any reference you want, but then you just kind of have to adjust everything.
Right.
So if you go into our reactor building and you're in the elevator and you're at elevation 117, it's 117 feet above mean sea level, based on the data that was in place when we first built the plant and had it licensed by the NRC. So it's a reference point. I think you can pick any one you want. It'll just kind of change, your reference point, where the pad would be.
Well, that's what I'm wondering. So if you use mean high water instead of mean sea level to determine worst case scenario, is the pad underwater?
No, because everything is kind of additive to what your reference point is. So if you pick a larger number as your starting point, then the calculations of where the wave heights would be less as well. So
Okay.
I'm not a meteorologist, but
Right.
Graphically, I probably can show you a lot better if I had a figure that gives you a better idea of how we add together, the lowest, the mean sea level, which is 0, and then the high tide, which is somewhere between 3 and 6 feet, depending on, where the moon is. And then on top of that, you add all the effects of storms and surge and waves.
Right.
And all of that added up to the numbers that I presented from that report that we had done in 2015.
John, I'm sure you have lots of questions. I can pass. You're going to pass to Kevin. Kevin?
Have you had a situation measured in any of these storms, northeasters that we had, how close any of the surge has gotten to the pad? Any studies indicated anything graphically that show?
I'd have to check my notes, but I think the highest surge that we've had on the site is either 16 or 18 feet above mean sea level, so some 9 or 10 feet below the pad. We have not had water, to the best of my memory and working at the plant for 10 years, that was anywhere near the areas, that the site is located.
Yeah, just one more. Is there a requirement as to why they need to be outside? They're not in a building or bermed or anything else like that, or is just for ease of access? Is that the issue?
It's really just selection of design, you know, there are systems that are in buildings, there are systems that have cast laying down, standing up. It's really preference. There are systems that actually are in silos into the ground. This site, without getting into a lot of details, because of where groundwater is just not well-suited for, you know, boring in and putting underground systems. They take up a lot more space, so space becomes an issue as well. But there are those systems out there, and we have to kind of evaluate them relative to the configuration of the site and, you know, going forward, what works best for us.
Thanks.
Mr. Lynch, not to take away any of the public's time, but are there similarities to the Yankee Row decommissioning or non-similarities we should be aware of? Our other power plant that's been decommissioned in Massachusetts?
Well, all three of the New England plants, Connecticut, Maine, and Yankee Row, all have a pad-mounted vertical type canister. As I mentioned, it's a slightly different manufacturer. It was NAC International, but essentially it's a natural circulation type of configuration where an inner canister is in an overpack. I don't remember the capacity of those, but you know, in rough numbers, I think Yankee Row has 13, Maine has 63, and Connecticut has 40-something canisters. So we have a lot of experience that was gained from those sites. They had to go through the same siting type criteria as we have, and ultimately they decided, you know, based on what was best for their sites and how it also interfaced with decommissioning.
Lise?
Thank you, I'm all set. Thank you.
Before, we were almost around time. I'll keep it running longer, though. Before we turn it over to the public, I got a couple of thoughts, Joe, and a couple of questions. First, you'll get me a copy of the PowerPoint and we'll distribute it and ultimately get it up on the website. The second is, can we get a commitment between all of us that we will be allowed to participate in the ongoing process of your decision-making on this?
I guess we'd have to understand what participate means. I mean, accepting input, that would be acceptable, absolutely. Yep.
And let me go on to a couple of the other questions. The selection criteria that was used for this first pad, would you be willing to share that with us so we understand how the first pad was cited where it was? I don't know if it's a public document. I've never seen it.
I don't either. You know, we've made many submittals to the NRC regarding, you know, how we arrived at the location. Let me look into what information is publicly available. Sometimes when you have an outside consultant do some work for you, there's confidentiality type stuff, so I have no idea.
Because
Yep.
what my thought would be is, I mean, it's unlikely that you'll reinvent the entire wheel, even as you are considering other locations, but that the criteria that was established will probably be similar, and it'll give us some guidance into areas that we might want to focus on. I looked at the map as well in terms of the mean high tide, and got two quick questions about that. As I looked at it, it looked to me like you had a margin of 2.6 feet under the worst-case scenario now. Is that accurate, just to make sure, between the 25 at the low end of the pad and the 22.4 was the high end of the worst case?
I believe that would be,
So it's about a 10% margin of error in there now.
yep.
The second one I had is, in the upcoming one, because we're in a funny little timetable here with the 19 years versus when it was first done, I think it's been generally accepted in the science that globally, sea level is rising. Now, if you read, and none of us here are that level of a science in hydrology, there's a general sense, I think, that it changes from location. It's like the Bay of Fundy, you know, you're not gonna get the same tides. Do you guys plan in this next go-around to cite this one, to do a completely new site assessment to determine really what is the mean high tide now? What is that mean sea level now versus what it was when the original plan was done?
Well, I can't say specifically because we haven't gotten to that point yet, but generally speaking, we'll use the most up-to-date information as the design criteria as input into, elevations, all the type of things. So we've had the benefit, for better for worse, of learning from Fukushima that a number of things had to be reevaluated, seismic, flooding, that type of thing. So we have some very new and updated analysis that was not necessarily directed towards siting ISFSI pads, but it's now part of our design basis, so that will all be factored in. And if it has an impact on elevation or location, that will come out of that process.
Just two other quick questions that I'll turn over to the public. First is, you were mentioning that on the whole time, from a licensing point of view with the NRC, the canisters are licensed for 20 years today. Now, I'm not going to ask you to speculate when the federal government will finally live up to its legal promises and requirements and create a national repository. But in the event, the unfortunate event that these canisters are there for more than 20 years, what kind of assurances does any community have that when the NRC is saying we'll license it for 20, but it might be there for 60 or 200, it's not like you can go in and fix it.
Right.
What's your thoughts?
I think the best way to explain it is that when Holtec licensed these casts, they went in for and asked for a 20-year license. They are preparing to extend these licenses to 40, 60, 80 years going into the future. I think it's very likely, if they did the design correctly at the beginning, these were designed for many more than just 20 years. I believe. Well, again, I'd rather not speak for the manufacturer, but I think you will be educated at a different level talking to the manufacturer than to me.
We look forward to having them. And one final quick one. To Pine's point, is the corner of the pad that's there now, is it 110 feet or is it 300 feet? Do we know?
I took it off a drawing and, from inputs, so I'd be more than happy to take a big, long measuring tape and take care of the whole thing, because I would rather not speculate.
Go to the top of bank, okay?
Yeah,
So,
so.
thank you, Joe. Wonderful. For the public's purposes, because we went a little over, we're gonna let you guys go a little over, and Joe's been very good about it. So anyone that wants to speak, you know the routine. We've got 1, 2, 3, 4, 5, 6. So we're gonna do 15 minutes, so you're gonna all get around 2.5 minutes apiece. And Rich, why don't we start with you on the left side tonight and move our way forward? Yeah, you never know. I just make it up when it happens.
Joe, good presentation. Has the NRC formally approved I believe Entergy submitted the flood hazard reevaluation report March 2016. Have you had any feedback from NRC? I know there was Q&A going back and forth, but have you gotten a formal approval yet of that report?
To the best of my knowledge, and I'd have to verify it, that they have accepted that flood reevaluation report and our response to that part of the Fukushima task force.
Okay, thank you.
Sure.
Second row. Who was in the second row there? Did you want it? Yeah. Make sure to identify yourself.
Yes. Henrietta Cosentino, Plymouth resident. Thank you for the presentation. It was very informative. I just want to go back to Pine's Point again. I think you can probably see that we in the audience anyway, and many of your panel, are disturbed by the sighting of the casks, because it does seem to be frighteningly close, even to the eye, visible and close to the shore. And we know that the rising seas are a moving target. I mean, what was predicted in 2012 is very different from what was predicted in 2015. The projection of rising sea levels has been accelerating with every single year. So it does very much unnerve me, I can't speak for anybody else, about the idea of a 2.5-foot difference between the maximum projected sea level based on 2015 projections and the actual placement and height of the casks. I also understand that while Holtec is preparing to relicense these casks, that it's also a fact that the casks have been known to crack after 30 years, and I wonder what in the world happens then. Thank you.
Jim?
Three quick questions, I guess first for Mr. Lynch, then a couple of comments. Joe, you said that I thought I understand you to say that at least the pad will accept the Class C, greater than Class C. Is Entergy going to move all of the greater than Class C onto pads? Because we all know what some of it isn't there now, and God knows how much more you're going to produce.
I don't know the answer to that because the disposal of the reactor vessel would be almost a specific project that would be something that we would go out to bid for. And the technology is constantly changing and getting better. There are manufacturers or companies out there that do a very good job of segmenting these vessels and making them transportable. So I would be speculating, but what we're doing is we're allowing in the design for the space in the event that we have to store some of that waste on the site.
Okay, you've got some greater than Class C on site right now, and it's not on the present pad. It's closer to the coast than the present pad is. Are you planning to move that?
I don't have any knowledge of what we actually have stored on the site, but if that's something you'd like to follow up, I'd be happy to do that.
Second question is, you said there are, and the numbers all work out right, there are will be a total of 4,114 assemblies, including the 580 that are now in the reactor. And I think that, assuming the plant actually closes it down into 2019, that sounds like the total number that'll be there. How many of those are high burnup fuel?
I'd have to follow up. I don't have a
Because
breakdown.
the requirements and the needs of high burnup fuel can quite drastically increase what the needs and timing is. So I think the panel would appreciate that type of information.
Yeah, absolutely. Any of the fuel types have to be evaluated by the cask manufacturer. It may modify or change how many are in a cask, and that is part of something that we'll take into consideration.
But I think the starting point is can you inform the panel how many of those 4,114 are high burnup fuel?
I'd be happy to follow up on that.
And the final question is, on your slide 15, you listed a number of hazards, one of which was not anything approaching an attack. Have you seen Dr. Gordon Thompson's review of available weapons that clearly will easily penetrate casks?
I have not.
I suggest that you look at it and then report back to the panel if there's any part of that with which you disagree, because his findings, and I think they're in materials that we've provided to the panel, tell you that those casks will not withstand readily available weaponry.
Yeah, I think that would probably be best suited for the designer, but again, you know, if you something you want me to follow up on, I'd be more than happy to.
And then a general comment for just on the committee. I'm concerned, and I think the panel should be, on how we're always taking today's snapshots. Mr. Mullen referred to the fact that, as did Pine, sea level keeps rising. We can't assume how long this stuff is going to be there. Entergy's seemingly consistent PSDAR estimates, and they're all remarkably the same, say, 30 plus years after a plant shuts down. There is no plan in effect to move any of this stuff. So when our panel is looking at what you should recommend to the governor, that the governor and the legislature should do, and what both should pressure both Entergy and the NRC about, is let's stop looking at just, oh gee, is this okay today, and take the steps that are going to be necessary to protect the public, and frankly all of us here today, those of us that are still alive, as time moves on, because I think you have to assume, you can't take a non-conservative assumption, that these casks may well be on pads 1 and pad 2, and I expect pad 2 to be very close in location to pad 1, for somewhere between 50 and 100 plus years. And you can't assume that the level of seawater is not going to rise 2.5 feet in 50 or 100 years. You can't assume that the wave height that they really can't measure because they take their sea level inside a place where wave height doesn't affect it is what we're going to deal with. take the conservative view of what we're likely actually to have to face, us, our children, and our grandchildren, and that's what I would hope you would base your recommendations on.
Thank you, Jim.
And
Mary?
Obviously, we live together because he took the main concern I have. The main concern comes from at Vermont Yankee, for example. They assume that all the fuel is going to be gone in 2052. 2025, somehow there's going to be an interim storage site available, and the stuff is going to start moving out. This is fantasy. It's not based on any rational. So we have to look at not the best case, fantasy, but the worst case. That's what this panel, that's what the administration has to deal with to be real. And where's the money going to come to deal with this reality for the long term? Look at the casts that we have. A perfect example. The Holtec casts that we have are designed for the short term. They have a 30-year, in 30 years, the NRC says they can crack. At Diablo Canyon, where these Holtec casts are, they're showing signs, early signs of stress corrosion cracking. It's on salt water also. Same in South Africa. And so you have Holtec, a limited liability company. Who's going to be responsible for this? Stress corrosion cracking is what you find that impacts stainless steel over the long term. Salt is a problem. Do we have cathodic protection for the cast and the pad?
I don't know the specifics of the design.
Well, this is something you need to know, because cathodic protection is something that can limit and prolong the corrosion.
Mary, can you say what protection are you saying?
Cathodic.
Cathodic, thank you.
Right. Also, NRC, and I sent the videos, says that there is no capability to inspect the canisters for cracks, and the only way you're going to know there's a crack is when you have the radiation detected. Each cast has half the cesium-137 that was released in Chernobyl. Not a pleasant thought. Dr. Singe of Holtec, again, I sent you the video, has said you can't fix them. And so, do you have spare overpacks or Band-Aids on site? If you don't, you should. And so, looking at the long term, it seems we've got a problem with the casts that we're using because they were the cheaper for assumption of the short term, which is not, and again, Jim talked about in Pine, flooding. What about security? Airplanes. That too is an issue.
Mary?
And so I think the point, my real point is that this panel, the governor, and Entergy cannot be allowed to look at the short term, which is to your economic interest. I understand that, but it's not to our interest. But thank you for your presentation.
Pleasure. Is there anyone else that wanted to speak? One more? Two more? Yeah, go ahead. Is there one in the back, too? Okay. Make sure you identify yourself, please.
Yes, Rebecca Chin. I co-chair the Nuclear Advisory Committee for the town of Duxbury, but my previous hat was the chairman of the Board of Health in the town of Duxbury. My concern is that monitoring wells that are on site now that we do for tritium purposes need to go on into the future. And when they built the first pad, they capped one of the wells and paved over it. And to my knowledge, they have not replaced that well in any area around the pad. And my concern is that the pad is banked so that water will run off it. You need to have more monitoring wells because we'd like to know in the future what's running off that pad and going into the groundwater. And the monitoring wells are really critical. And they need to go forward because we're not going to know where the radiation, unless it's in the air and it's picking up by those monitors, but we're not going to know what's going into the groundwater and potentially with a tide that comes in and out twice a day. And I would like to see monitoring wells be established in the perimeter areas of the current pad and the next one that's going to come online. Thank you.
And to your point before you leave, we get a lot of great comments, and a lot of us take good notes. Not as good as Alan's, but a lot of us take good notes. If you would be so kind, and everybody else, we appreciate the input. Put it in writing to us, because as we try to assemble.
You'd love an email from me?
Yes.
Okay.
Thank you. Next. We have one more person? Okay. Well, that's great. Thank you very much. And Joe, let me just add, just on a personal level, you did a great job on the presentation. We really appreciate it. I can, without being certain, I can be pretty certain we'll ask you back again for further information.
You think?
I think it might happen. Before we go, and we're almost on time, I just wanted to give you a couple of overviews of what I'm suggesting for the first of the year. In January, and this has come from Jack in the past and others, my suggestion is going to be we do our meeting around radiation issues in January. And I also am going to suggest that we bring in Dr. Bill Irwin from Vermont, if he's willing to come down and visit with us. I understand through Jack Priest that he might be, so I think that topic. I feel like we're in this process now of beginning to transition from education and information gathering only to starting to get more proactive in it and the questions that went on tonight. So that's my suggestion for January. In February, and I've chatted with John Flores about this, I think it would be a great idea to take this down to the Cape. I think it would be a great idea for Cape Cod residents to have an opportunity in their part of the state to really come and participate. I think it ties into one of our goals. I know everyone shares this goal, which is to get a focus on informing the public, getting them more interested in what the topic is, because despite Joe's very clear explanations tonight, some of these are complicated issues. So what I'm suggesting for the February meeting, if the panel feels the same, that we do it on the Cape and that we focus on state and national legislative initiatives, because there is a lot going on, both in the state. I know Senator Wolf has wanted to give us a briefing, Senator Sears, Senator DiMacedo, our legislative delegation in the House have all wanted to talk to us about it. That's what my suggestion is for February. In March, I'm going to suggest that we continue the discussions I've had with MIT and perhaps do a meeting in Boston or at MIT as part of their nuclear symposium. Again, the idea would be both to get input from other experts at that meeting as well as state elected officials and federal delegation officials. And one of the things that I think we need to do a better job at, we're early on and we're doing a good job, don't get me wrong, is getting regional and statewide serious people involved in this process to understand that the impact of the topics related to the decommissioning of Pilgrim really is statewide and regional. It's not just us. We're not in this. The legislation that some folks may have seen in Congress, it was supported by 3 Democrats in a Republican-controlled House. Doesn't mean that it's not great legislation. Just means it's going to be difficult with just that group of people to move a very good piece of legislation. So I think March, I would suggest we do it in Boston or at MIT, depending on how those discussions go. Then in April, I'm going to suggest that we focus the discussion on the work of the working groups, that we need to start getting ourselves organized for that. And what I would suggest is that that really be a working meeting where we start going over each in about a 20-minute session of the working groups, what topics have bubbled up, and what I'm trying to set here is a framework, and to have a framework so that as these documents get written without overburdening anybody even more than we already have, to start getting it together in terms of organizing how we'll do it. That's what I recommend for April. In May, I recommend the first drafts come back, and we have a review of that first draft, including recommendations. I've been keeping a little list of my own, and I'm up to 11 recommendations that I think are worthy of the panel talking about. I would encourage all of you to do the same thing, that if a topic comes up that you think warrants a recommendation, we should make sure that the working committees and the panel have a chance to really vet it and then take a vote on it. And then in June, the primary purpose, I believe, of the meeting would be the first annual report that we're going to issue, statements regarding that. And in June, I would really like to allocate much more time for the public with that first report to give us their thoughts on what we've done in the first year and to make sure we're not missing anything. The second half of the year, my suggestion will be, and it's a long way out, is to do things like the Holtec and other dry cask vendors, companies, to come in and to map that to what the working committees, the working groups have come up with in terms of the key priorities, and to map those next 6 months, or 5, because we're not going to meet in August or December, to map those then. That's what I'm thinking and would suggest. Any comments, any ideas to the contrary, or tell me to go forth and put them together? Yes, Joseph?
Sean, those sound like all good suggestions. Could you put those as a revision to the July chart that you had prepared and sent us? Because those are major changes to that chart, which you had titled for discussion purposes. And then get it out to all of us. I think we'd appreciate it. Thank you.
I didn't see one. Yes, sir.
Hi, my name is Lee Cook.
Why don't you come up to the microphone? Since we're giving you extraordinary access here, Lee, we don't usually let this happen.
Hi, my name is Lee Cook, and I'm a resident of Kingston. And I don't know about anyone else, but after all of the conversation about the various potential weaknesses in the canisters or the containers, and the theory and practice of containing this material, it seemed to me that Holtec, I guess, is the principal company, that as I listened to the list of ideas for forthcoming meetings, I was a little bit disturbed that the emphasis on looking at Holtec and this whole concept of these containers was far down the list. And to me personally, after listening to the wonderful presentation tonight, I was very concerned about the various weaknesses and potential weaknesses in the approach to containing this material. I would personally like to see a much sooner discussion and examination. And someone mentioned a Dr. Singh, or someone who apparently is a very effective and knowledgeable person. I would like to suggest that we may consider calling upon that individual to come before this group, because I personally, as just one individual, would like to hear more from him.
We appreciate it.
Thank you.
Thank you. No, we're gonna make a call here to motion to adjourn.
So moved.
So move, second.
Second. All in favor?
Aye.
Aye. Any opposed? Yeah, you could absolutely talk.